Equipment. In this module, we will see how to prevent and solve problems regarding diving equipment. We will also examine how to carry out the correct maintenance that helps prevent problems arising. Equipment maintenance problems. You don't have to be able to design diving equipment in order to use it, but a basic knowledge of how the equipment works is fundamental to recognizing when it is not functioning correctly. At the least sign of a malfunction, the equipment must be taken to a specialized service center. At first, many problems may seem minor, but they will only get worse with time and can eventually become the cause of an emergency situation. Do not attempt to repair equipment. It is always best to seek the assistance of a professional. This takes the form of an annual inspection, even if the equipment is working well, particularly after a period of inactivity. For example, oxidation can form in the second stage of the regulator and cause it to free flow. Sometime before the dive, it is important to examine all the components of the equipment that are most subject to wear and tear, and a spares kit can help solve many minor problems. Underestimating the importance of a worn piece of diving equipment could lead to problems underwater, for example, losing your fin because the strap breaks. It is essential to follow the manufacturer's instructions very carefully when carrying out general maintenance on your equipment. Do not do any maintenance if you do not know what to do or how to do it, and above all, do not attempt to modify any part of your equipment, as this could compromise the correct functioning of the part. Sand, salt, debris and chlorine cause diving equipment to deteriorate. This is why you must rinse it in fresh water after every time you use it. For reasons of hygiene, any equipment that comes into contact with the skin or the mouth must all be rinsed particularly well. Scarce hygiene could cause diseases of the skin, eyes and throat, especially if the equipment is used by a lot of different people. Periodically, after rinsing the equipment well, use a suitable disinfectant, preferably a salt-based quaternary ammonium product if possible. Problems involving the use of equipment. Thanks to modern technology, the equipment we use today is designed with diving safety in mind, on condition that each product is used and handled correctly. You must only ever dive with a complete set of equipment that is of the right size and suitable for the type of dive you have planned. You must also have other items of equipment that could be useful in case of an emergency, such as a surface marker bag, a line and reel, and a signaling device. The equipment you decide to take with you must be chosen on the basis of the type of dive being planned and the limits established. Experience and common sense will help you in making these choices. For example, dry suits, dry gloves and full-face masks are used to reduce heat loss when diving in very cold water. When diving at sites known to have low visibility, such as caves, wrecks or in murky water, you should choose instruments and gauges with sound alarms and backlit displays which provide you with the information you need to know during the dive. You must always dive with items of equipment you are familiar with. For example, when you dive for the first time with a new or unfamiliar buoyancy compensator, you could have difficulty using the power inflator devices or dump valves. The first few times you dive with heavy or bulky items, for example a video camera or camera housing, or with any new equipment, plan undemanding dives in easy environmental conditions so you can get used to diving with this new equipment with no other worries. Before using any special equipment, such as an underwater scooter, always consult a qualified instructor who will teach you the techniques you need to know so you can use the equipment safely. When buying or hiring equipment, always make sure that it is the right size. A wetsuit that is too big will not provide you with adequate thermal protection. Mask, snorkel and fins. Make sure that the strap and face seal of the mask are not worn or damaged, and that the method for adjusting it is intact before every dive. If you lose your mask during a dive, all you have to do is just wait for your buddy to find it and bring it to you. If your buddy is some distance away, you can try looking for it yourself. If you are close to the seabed, the mask is probably right under your fins or close by. Cupping your hands over your forehead and tilting your head downwards will make it easier to see, because some of the air that you breathe out will be trapped by your hands, and the bubble of air created in front of your eyes will help you see better. If the mask strap is broken, hold the mask onto your face with one hand. Fins must be the right size, and this depends not only on your foot size, but also on the type of footwear you are using. If fins are too tight, they could block the flow of blood to the feet, causing a reduction in oxygenation and the onset of cramp in the sole of the foot or calf. In order to relieve cramp, remember to extend the muscle very slowly. Keep it fully extended for 10 to 15 seconds and then release it gradually. Wearing fins that are too large reduces their efficiency, and there is a risk that you could lose them. Swimming with just one fin, as you learned on the PSS open water diver courses, can be tiring and lead to breathlessness when swimming long distances. Before every dive, check that the fin straps are not worn and that the buckles are closed securely. If a strap is worn, replace it with a spare one. Suits. When selecting a dive suit, the rule is to choose one that will provide you with adequate thermal protection for the type of diving you will be doing and the temperature of the water. A light suit is fine for short dives in the tropics, but in colder water you could risk hypothermia. On the other hand, wearing a semi-dry suit used in cold waters could lead to you getting heat stroke if worn in the tropics. A table may help you when choosing your dive suit. You also need to choose the correct size. The thickness of the suit is not enough to keep you warm. You also need to limit the amount of water that can get inside the suit. If a suit is too large, a lot of water will get in and increase heat loss. However, a suit that is too tight, particularly around the chest and wrist and ankle seals, can cause breathing difficulties and circulation problems. A suit that is too tight around the chest can compress the rib cage and make it more difficult for the lungs to expand. This reduces the exchange of gas at the alveolus capillary level and leads to an increase in the partial pressure of carbon dioxide in the blood. This increase triggers the respiration's control center to increase the frequency of the respiratory acts. The result is a sensation of air starvation that could turn into real breathlessness and even worsen to become a hypercapnic syncope. Excessive constriction around the neck could compress the carotid glomus, inducing bradycardia, meaning a decrease in the frequency of the heartbeats. Ankle and wrist seals that are too tight can also slow down the blood flow to the area and increase the risk of suffering an embolism. Using a dry suit requires special training. On the PSS Dry Suit Diver Specialization course, which provides such training, you learn how to use and maintain a dry suit and how to control your buoyancy and solve the particular problems involved in using this special piece of equipment. Flooding of a dry suit is usually due to the zip or seals leaking, or the material of the suit tearing. If this does occur, you must obviously abort the dive and ascend. A rapid ascent may be caused by a badly regulated dump valve not allowing the excess air to escape. In this case, you can dump a large amount of air quickly by pulling the neck or wrist seals open. Another problem could be that the inflation device is defective and emits air into the suit continuously. In this case, open the dump valve immediately and disconnect the feed hose to prevent more air being emitted into the suit. If a dry suit is too large, in a vertical position the excess air will collect in the upper chest area and around the neck, causing the same problems as a suit that is too tight. If you are in a head-down position, the air will collect in the boots, forcing you to stay head down. In this position, it is impossible to dump the excess air because the dump valve is lower in respect to where the air is collected. To avoid a risky ascent to the surface, you must push your body upwards and force your head and shoulders into an upright position. All these emergency techniques are part of the practical sessions of the PSS Dry Suit Diver course. Weights. Remember to do a weight check every time you dive in a different environment or use new equipment. If you use too much weight, your buoyancy compensator will have to be almost fully inflated, and this increases the hydrodynamic resistance and makes it much more difficult and tiring to move through the water. You could even become breathless or suffer from cramps. If you wear too little weight, you will find it difficult to get under the water and to maintain the correct buoyancy, particularly during the safety stops at shallow depths when the cylinder is lighter due to the air that has been used during the dive. Before diving, always check that the weight belt is tight enough around your waist and that the buckle works and is closed correctly. How the weights are distributed is also important. If they are positioned incorrectly, it will affect your trim. There are belts with pockets for the weights and buoyancy compensators with integrated weight systems on the market today. These allow you to alter the amount of weight without having to remove all the weight completely in case of an emergency. Remember that these integrated weight systems are not all the same, so it is important that you and your buddy know how to release each other's weights before the dive. The buoyancy compensator. There are basically two consequences of a malfunctioning buoyancy compensator, an increase or decrease in buoyancy. The first problem is usually caused by air being emitted continuously into the air system. This leads to the risk of an involuntary and uncontrolled ascent. If during the dive you realize that you continuously and without any apparent reason become more buoyant and are forced to repeatedly dump the air from your buoyancy compensator, quickly detach the feed hose from the power inflator and dump the excess air. You can orally inflate the buoyancy compensator to maintain control of your buoyancy. Once on the surface, you can check if the problem persists by deflating the buoyancy compensator completely, connecting the direct feed hose to the power inflator and opening the cylinder valve. If the buoyancy compensator gradually inflates on its own, the malfunction is usually due to bad maintenance of the power inflator. Oxidization, debris or dirt has compromised it functioning properly. Rinsing the power inflator connection well after each dive and having it checked annually at an authorized center are the simplest ways of preventing this problem. On the other hand, loss of buoyancy may be caused by the dump valve not closing properly because sediment has become lodged under the seal, or there may be a hole in the corrugated hose or air sac. Ask your buddy to check to see if there are bubbles leaking from your equipment and abort the dive. To prevent problems of leaks during a dive, you should carry out a safety check. Together with your buddy, go just beneath the surface of the water, stay in an upright position and turn around so your buddy can check to see if there are any bubbles coming from the cylinder valves, regulators or the buoyancy compensator. Then change roles. Only if there are no leaks can you then go ahead with your dive. If this is not the case, you must get out of the water and rectify the problem before starting the dive. Like our diving suits, a buoyancy compensator must also be the right size. A buoyancy compensator that is too small may prevent you breathing comfortably when it is fully inflated, or it may not provide you with sufficient lift to support you in the water. On the other hand, a buoyancy compensator that is too large may make moving in the water difficult because the cylinder tends to move around as you swim through the water. Remember to tighten the straps that attach the cylinder to the buoyancy compensator, and then lift the aqualung up by the shoulder straps or the handle of the backrest to make sure that the cylinder doesn't move. If you realize that your cylinder is slipping down during a dive, move into a horizontal position. Hold the cylinder in place with your hands and get your buddy to tighten the straps and fasten it in the right position. Regulators. On the surface, you can make sure that there are no leaks from the regulators by making a buddy check. You can make a further check in the water by applying the safety check techniques seen a moment ago. If the mouthpiece, membrane and purge button of the second stage are not integral or are positioned incorrectly, you could inhale water as well as air. To prevent this happening, you should regularly inspect the various components and, before fitting the regulator to the cylinder, try doing this test. With the air inlet of the first stage closed with its airtight cap, try breathing from the mouthpiece. If everything is in order, you will not be able to inhale air. If this is not the case, you must locate the source of the leak and try to repair it or change regulators. Always check that the tie wrap holding the mouthpiece in place is in good condition. Otherwise, during the dive, you could suddenly find yourself with a mouthpiece, but no second stage. A possible malfunction of the regulator is a free flow. If you are using a cylinder with a double valve and two separate regulators, use the regulator that is working and get your buddy to close the valve to which the free-flowing regulator is attached. After having stopped the flow of air, begin the ascent. If you are using an octopus system, change over to the auxiliary second stage. If the problem is due to sediment in the casing of the second stage, it may be enough to just press down on the purge button a few times while holding the mouthpiece downwards. If the free flow continues, bend the low-pressure hose of the free-flowing second stage and hold it tightly where it is bent. If the flow of air stops, keep the hose in this position and begin the ascent with your buddy. The free flow may also be caused by a malfunction in the first stage of the regulator. In this case, bending the hose will block the flow but will cause the second stage you are breathing from to begin free-flowing. At this point, you have to use the technique of breathing from a free-flowing regulator, thus reducing the risk of running out of air. Remember that your dive buddy must always be close by and ready to begin sharing their air supply if necessary. If you are considering diving in cold water, always make sure that you use a suitable regulator with an anti-freeze system. In fact, when diving in particularly cold water, an ordinary regulator may begin free-flowing because ice crystals form inside the various components, compromising its functioning. The pressure gauge. A point, commonly the site of leaks, is the connection between the high-pressure hose and the pressure gauge. Inside the hose coupling, there is a revolving pivot with two small O-rings. Oxidization and other deposits may gradually wear down the O-rings and cause a leak. The leak is usually very small in the beginning, but it can quickly get worse and there is the risk of having to interrupt a dive. Obviously, the only solution is to take the instrument to a specialized center for repair. Careful rinsing, using it correctly and having it checked annually by a professional technician prevent this problem. A second malfunction involving the use of a submersible pressure gauge, although unlikely, is a breakage in the high-pressure hose. The most common point where it is likely to break is near the metallic terminal. A hose protector will help prevent this, but remember to move the hose protector every time you rinse the regulator, so the exposed area can dry completely and you can check that the hose is not worn. To avoid damage, hoses must not be put to improper use or bent excessively for a long time. During the dive, the pressure gauge must be firmly attached to the diver using the various types of hose retainers. A dangling pressure gauge can easily get wedged between rocks on the seabed, and pulling on it will cause damage to the instrument as well as the delicate marine life. Finally, a dangling pressure gauge is dangerous as it could also get caught as you are getting into the water. If the high-pressure hose breaks during a dive, you must surface. Your dive buddy should be ready to make an emergency air-sharing ascent. There are diving computers on the market that also give you a reading of the pressure in the cylinder. Some use a hose, like that used for a traditional pressure gauge, while others work using radio waves sent by a transmitter connected to the first stage of the regulator. Integrated pressure gauges are now precise and reliable. The only defect is that in the event that the computer fails, you no longer know how much air there is in your cylinder. When using a pressure gauge, it is necessary to make sure it is accurate. With the cylinder still closed, check that the needle is really in the off position. If this is not so, the pressure gauge may not be calibrated correctly and the reading is therefore unreliable. Check the reading periodically with cylinders at various pressures and compare them with those of a pressure gauge known to be accurate. In the next module, we will look at some tips for resolving and preventing problems caused by environmental factors during the dive and the effects these factors have on the human body.